These are our findings from Formal Lab number 2, resistive forces. So our research question for this lab was, what is the relationship between the velocity of an object falling through a fluid and the resistive force from that fluid? The result that we observed from our experiment was that as objects move through fluids, eventually the resistive forces will grow to counteract the gravitational force and terminal velocity will be reached.
Resistive forces refer to contact forces that oppose movement between two surfaces. These resistive forces will be parallel to the surfaces. There are three types of resistive forces, and they are friction, viscosity, and drag. Since this lab is focused on movement within a fluid, this lab will focus only on viscosity and drag.
M is a constant of proportionality that is unique to each fluid. When an object moves through a fluid, it drags the fluid along with it on its surface. The fluid's resistance to move is the viscous force, proportional to the velocity of the object. C drag is the drag coefficient. P is the density of the liquid, the force the object exerts on the liquid in front of it to move the fluid in the direction of its motion. Therefore, drag is the force of the fluid in front of the object opposing its motion. This is proportional to the square of velocities.
Reynolds number is defined as the ratio of the drag force to the viscous force. A large Reynolds number indicates that the drag force dominates and is the force you must pay attention to when modeling the situation. A small Reynolds number indicates that the viscous force dominates and therefore is the force that you must pay attention to in that situation.
This model is our ball in the fluid. The black arrow represents the drag force, the orange arrow represents the viscous force, and the teal arrow represents the gravitational force.
We designed our experiment to have the independent variable being the fluid that the object travels through. The dependent variable is velocity, which we will use to calculate viscosity and the relationships. The constant was the metal ball bearing that we used to drop through the fluids. We used the same one for each trial. We dropped the metal ball bearing through water, dish soap, and corn syrup and recorded their velocities through those fluids.
Our procedure was as follows. Fill a graduated cylinder with a different liquid, either water, dish soap, or corn syrup for each trial. Hold a meter stick in back of the graduated cylinder in order to accurately track the movement. Drop a metal ball bearing from the mouth of the graduated cylinder. Record the movement of the ball as it falls through each of the fluids. Use the tracker software to analyze the data for position, velocity, and acceleration.
In our water trial, the bearing appeared to reach a terminal velocity, but due to limitations as a result of the experimental methods, it did not continue along this path.
For our dish soap trial, the position appears to change at a linear rate. Although the velocity fluctuates a little bit, overall we said that it does reach a terminal velocity because acceleration is near zero.
For our cornstarch trial, our velocity seems to fluctuate between positive and negative until about 10 seconds, and between 10 and 12 seconds, the velocity becomes relatively constant, so we can say that it reached a terminal velocity.
Initially, a negative acceleration is observed because the gravitational force exceeds the sum of the drag force and the viscosity force. Eventually, the drag force and viscous force grow so that they equal the gravitational force, and so that there is no acceleration, and therefore velocity is constant. This is because as velocity increases, the resistive forces, which are dependent on velocity, will also increase. And this is displayed as a flat horizontal line on the velocity versus time graph.
As with all experiments, we encountered error and design limitations with our lab. When the ball was dropped from the top of the graduated cylinder, its path was likely not a perfectly straight line as it fell to the bottom, meaning that there are now x and y components to the ball's movement as opposed to only in the y direction. Also, the graduated cylinder or the liquid within the graduated cylinder may not have been tall enough or have great enough volume for the ball to reach its constant terminal velocity.